Okay, I'm having a look at a few questions on Chapter 7 revision for the Unit 1 Maths Methods. So this is just a sample from the chapter tests there. So we've got sketch the graph of f of x equals 2 outside of x plus 1 to the power of 3 plus 2. So that means we're going to be doing a sketch of a cubic in the form of where we've got the inflection point there, or possibly coming down if it was a negative. So what we're looking at is that point there where it's going to inflect. We get that from our equation. So it would normally be a outside of x minus h cubed plus k, where the hk is that inflection point. So we've got that at 1, 2 there. And then we want to get our y-intercept, x-intercept to be able to graph that. So our y-intercept is going to be when x equals 0. So we've got 2 outside of 0 plus 1 cubed plus 2. 0 plus 1 is 1. When you cube it, you get 1. When you times it by 2, you get 2. 2 plus 2 is equal to 4. So we've got our y-intercept at 4. Our x-intercept when our y is equal to 0. So 0 is equal to 2 outside of x plus 1 cubed plus 2. Take that negative 2 over there. 1 cubed. Then divide by 2. So we get negative 1 is x plus 1 cubed. So we know that the only thing that will give us negative 1 when we cube it would be negative 1. So that means that, or the cube root of negative 1 is going to be negative 1. So then we will take 1 over, and that will mean x is equal to negative 2. So we've got our basic sketch then, where we have an x-intercept over here at negative 2. We've got a y-intercept at 4. And we've got that inflection point at 1, 2. So looking at that, we might need to check a value there then. I've got my negative 2, I've got my 4, checking that one up here, 1, 2. So let's have a look at that graph and see what we may have missed. So we've got 2 outside of x plus 1 to the power of 3 plus 2. When we graph that, so what I've got and what I made my error here, if it's x minus h, if I've got x plus 1, then that needs to be a negative 1 there. So this actually is over on the other side, not there. So that when I come up, turn and up like that, gives me my graph. So that's where I made my error, remembering because there's the plus 1 there, that is going to be a negative 1. Coming down to our next question here, we've got a outside of x plus b cubed plus 2. We're determining the values of a and b when we have this information. So we've got our 1, 2 here. So that means we automatically know our f of x is going to equal a outside of x minus 1 cubed plus 2. And then we want to solve for a. So we're going to put that 3, 6 in. So we're going to 6 is equal to a outside of 3 take 1 cubed plus 2. So we've got a and 2 cubed plus 2 is equal to 6. Now when we do 2 cubed, we get 8. So 8a plus 2 is equal to 6. Take away 2 from each side, from both sides, so we get 4 is equal to 8a. So a is equal to a half. So we can then write that equation. F of x is equal to a half outside of x take 1 cubed plus 2. Okay, on to the next one I've got in there. I just wanted to put in an example in this video where we had in intercept form, so I haven't put a coefficient in the front there, but here we've got the 3 intercepts, so we have 3, 1, and negative 3. So then when we graph that, we've got 3, 1, negative 3. Now you might not be you may not be sure if it's going to look like that or look like that. So a great way to help you with that is to find that y-intercept. So when x equals 0, it's going to be 0 take 3, 0 take 1, 0 plus 3 that we're multiplying. So negative 3 times negative 1 times 3. Negative 3 times negative 1 is positive 3 times 3 is 9, which means that y-intercept comes up here at 9 or a little bit higher. So that means we would have our picture looking like that. The other thing, if you're not sure, is to sub in some extra values if you're not sure what that is going to look like. Now, it could also have come up like that and down as well. We're just sketching it. So if we want to get a better idea to make sure our sketch looks more accurate, we can always pop it in the calculator, do a little check, which is always a good idea anyway. And then we see our picture, and it does go up quite high there. So if I put my Y max up to 20, we can see it does come up quite high up there and down. But we were just sketching, so we didn't have to have too much accuracy in the height there. Now the last one is that interesting addition to that chapter 7 where we're finding that coefficient of our binomial expansion. So what we've got here is our x minus 4 is raised to the power 10. We're looking for the x to the power of 8 part of that. Now we know when we expand, we're always going for our first one. So it'll be x to the 10, x to the 9, x to the 8, etc. and onwards, which means the first bit, we've got this one where we've got our no, the minus 4 is not in there, that's to the power of 0. Then we've got times the minus 4 times minus 4 squared times minus 4 cubed, etc. But we also need those coefficients that go in front as well. And we get them from our Pascal's triangle or using the NCR button on our calculator. So because we've got that highest power of 10, we'd be looking at 10.8. Our other option is we could have done 10.2 because it's symmetrical, because the x is raised to the power of 8, but the negative 4 will be raised to a power of 2. Either way, we can do our math, go across to our probability, NCR, and we'll put in the 10 and the 8, and we get 45. And if we had, and we could just bring that down to save us going back into it, if we'd done the 10.2, you can see we'll get 45 as well. So going up here, we're focusing on this one here, where we've got the x to the power of 8, and we've got negative 4 squared there, and we're going to put that 45 in front. So this is the term that we're focusing on. Now when we do negative 4 squared, we get 16. And we need to do that 45 times 16 to get that coefficient of the x squared term. So in front of that x squared term would be 720.